Welcome to Intro to Linux and Web Episode 2. Today we're going to talk about the top-level directories, and then we're going to talk about directory structure a little bit, and then we are going to talk about some different commands that you can run to navigate these things, as well as I'm going to do a quick little tutorial if I have time. So jumping right into it, a directory is the same thing as a folder. So when I refer to directories, I'm talking about folders. So the top level folder or directory is always going to be the root level directory. It's represented by a slash. If you are from Windows, just clear your brain of backslashes. They mean nothing to you anymore. They'll mean something to you further down the line, but for right now, you only care about forward slashes. So every time you're typing a directory, you want your forward slash. That is the one that is the same thing as a question mark on your keyboard. So do keep that in mind. So from there, underneath there, there are a assortment of top-level directories, and we're going to go through each one and which ones are super useful and which ones matter to you. And even if you can't remember all of them right now, this slide deck will be up on my website, howtonix.info, as well as we get further along, these directories will mean more because they'll start being used more. For right now, though, if you can just bear with me and listen to them, we can form some schemas in your brain so that you can reference them later. So the first one I'm going to talk about is /user. So /user is where you would put multi-user utilities and applications. So anytime you have something that you want a user to be able to run, you generally throw it in here. There are some subdirectories in there called local and share, and then local share, and those are pretty much exactly what they sound like. They are local to that system, and then shared as in many users can use it, or many utilities can use it. So within there are going to be user bin, sbin, lib, and lib64. So quick little note about this is /bin, /sbin, /lib, /lib64, all of those are their own top-level directories, but in more modern OSs, you're going to see that those are just they're just links back to user, and then so it would be like user bin and user sbin and user lib and so on and so on. And the reason for that is because we're trying to move towards more consolidation and organization in Linux. Also, when I refer to a link, I'm referring to a shortcut. So that's all that really is it's just going to that other location. So first things first, a binary. So /bin stands for binary, and then sbin is system binary. A binary it's not a text file, but it's a file that is readable by the computer. It generally has some sort of program in it that if you looked at it, it would just look like gobbledygook, but to the computer, it can totally figure out what's going on. So the user binaries are going to be in /bin, and then the system binaries, like system level utilities that need to run, are just generally going to be in sbin. Not terribly useful to you yet, but soon. So then the next thing in there is going to be lib and then lib64. Lib is just going to be shared libraries and kernel modules. When I refer to a library, I'm just talking about a piece of code that can be referenced in many different programs. So it's generally going to be like a function or a class that many things can reference. And we'll talk more about what a kernel is later, but for right now, that's basically a high-level overview. Lib64 is going to be the same thing, only for 64-bit things. So the next thing there I have is /opt. I think of it as optional. This is where you're going to put on extra applications or extra utilities that you've written. Don't know where to put them, you just put them there. You'll find that a lot of external programs that you install will default install into /opt. So if you can't find them, maybe look in there. So the next thing is going to be /etc. That is the way that is pronounced. I think of it as the tools and configuration location. This is where you're going to find all of your config files for the most part. At least all of the system level ones that really matter are going to be found in /etc. The next thing there is /root. So brief little thing. So the root user is the default administration user in Unix and Linux. So anytime somebody talks about you need to be root to do this, they're talking about you need to be the default administration user to do this. So it has its own special directory for security purposes, and that is where it is, /root. Not available on every single operating system, but most modern ones will have a /root. The next one is going to be /home. So when you generally log into Windows or your Mac, you'll notice that if you open up File Explorer or Finder or something like that, you'll have your pictures, your documents, your downloads. All of that is in your home directory for that system. So in Linux, it's in /home. So if I myself were named Jesse, I would have /home/Jesse. And in there is where I would put all of my things that I need. So a home directory is also represented by a tilde. And then that tilde would be used like if I wanted to go into /home/Jesse, I could go into tilde Jesse, and then just that would represent all of home rather than typing out all of those extra characters. So if you see that anywhere, that's what they're referring to. A quick little note on that is this is why it looks like that. The reason we use a tilde is because if you look over here at the top right, you will see that there used to be a home button on terminal keyboards, and the tilde was also on that button. Okie dokie. If you look at the slide deck later on, you'll notice that this is a link to the Wikipedia page to learn more about this particular terminal keyboard that was used in the early 70s. I spoke about how Unix and Linux are kind of old, so a lot of the things that we talk about, I'm like, well, this convention started in sometime in the 70s. But going forward, there are plenty more top-level directories to talk about, so let's go. The next thing I'm going to talk about is /mount. So if you were going to mount a temporary file system, this is where you would put it. You're not going to be doing a ton of that yet, but do keep in mind for the future. After that, I have /boot. That is where files for the bootloader go. You generally see the bootloader very temporarily when opening up or when turning on Linux or Unix for the first time. You used to see it in Windows. I believe it has been sort of obfuscated away. You can still see it if you smash certain buttons, generally like an F key, to go and look at that in Windows or Mac or Unix or Linux. And that is when you're first booting up. This is what tells the operating system what to load when. Again, not terribly useful to you yet, but definitely something to keep in mind for troubleshooting later. Next is /media. So if you, this is sort of a new directory that hasn't always existed, but is going to be in all modern OSs. When I refer to modern, assume that I'm saying within the last 5 years, because Unix and Linux haven't been around that long, but when I say modern, I'm talking about the last 5 years because we have done quite a bit to operating systems in that time and done a lot of reorganization. So just throwing that out there. So if I were to plug in a USB stick and I were trying to look at the files on there, it would probably be default mounted into /media. So if I have a USB stick called JesseBot is really cool, it would be /media/JesseBot is really cool, and then in there would be my files. The next thing is going to be /dev. So /dev is where you're going to find device files. So you'll find things related to your CPU and your memory and other things in there. You'll also find a file called /dev/random, and random is a random number generator. And then the other thing to note about that that may or may not be of interest to you is /dev/null. That is where you route things if you want them to disappear forever. So do keep that in mind if anybody tells you to route anything into dev null. It will be gone forever and you will not be able to get it back. Okay, so the next thing is /serve. That is data for services provided by the system. I think it's pretty much deprecated. Looking in at least my my server, I didn't see anything in there, and from what I could research, it seemed like this is where you used to put things like web server files. It was supposed to be a replacement for things that you would normally put in, say, var www, but doesn't seem to be in use anymore. And I don't know if it was just in 2006 we had these grand fantasies and it just failed miserably, or what really happened with that. But you will still see it, and it is generally empty to my knowledge. The next thing we have here is var or var. So slash var stands for variable data, and that's where you would have, say, your logs or temporary files that you need for a particular system when it's starting up. You'll generally have things in var run or var log or var logs. So if you're ever looking for, oh, I can't find this error log, there's a good chance it's in var. It may not be, but there's a good chance it's in var. So the next thing here is slash proc. Slash proc is where you're going to find a virtual file system documenting kernel and process status as text files. So this is where you're going to find open file descriptors. You'll also find some more data on your CPU and memory. So slash proc slash CPU info and mem info are going to have like how many cores you have, how much memory you have, things like that. And then you'll also find some other things about process data in there as well. We will go over this more as we talk about troubleshooting things. Okie dokie. Alright, so this is the last page of top-level directories, I believe. So slash temp is exactly what you think it is. This is where we put temporary files. If you have anything like that's going to generate a bunch of files, or you just need to put somewhere some sort of data very temporarily that you don't care about long term, that's where you would put it. A lot of system services will generate things in there, and then they get cleared out as soon as you reboot the system. Rebooting is not as frequent on Unix and Linux as it is on, say, maybe Windows. So things in temp might actually be there for quite some time. I've definitely seen boxes, and when I say boxes, I just mean a machine, that have been up for well over 400 days, and I know people who have kept their systems up even longer than that. The great thing about Linux is that when you're upgrading, you don't necessarily have to reboot the machine, so there tends to be things that stay in temp for a very long time, but do keep in mind that nothing there is permanent and will be wiped out should you reboot, lose power, etc. So the next thing I have is slash sys. So this is new. It's again not something that really existed until kind of recently. It contains info and statistics about device and device names. You're going to find all sorts of things related to, for instance, IP configuration in there. We will talk more about this in the future, but do note that this is generally what it is. The next thing, again, new, is slash run. So slash run is temp file storage mounted during early boot. So you notice that I said var run earlier. Slash run is supposed to be the new var run. This is where if they needed, if any, when I say they, I mean any programs that are running at the very beginning of you booting up your machine, if they need to temporarily put data somewhere, they'll generally put it into var run. And then, again, that gets cleared out later on. So the next thing I have here, and final thing I believe, is lost plus found. Lost and found. So this is where unlinked files that have inodes, and an inode is the number associated with a given file, because file names are really just for users, because there's no way you're going to remember the number of every single thing. Very much like DNS, where there's no way you're going to remember the IP addresses of all your favorite websites. It's way easier to remember Facebook.com than it is to remember all of Facebook.com's IPs. So inodes are going to be about the same thing, where they've got a number in the file system as far as the computer is concerned, but they have names for users to look at. Sometimes when things get corrupted and horrible, you will have the inodes and the file names sort of detached from each other, and you have to run something called FSCK, which stands for File System Check, And when file system check is running, it needs somewhere to put all of these extra things that do not have linked inodes and names. So this is where it throws it. You might not see anything here right now, but if things go extra horrible for you, suddenly you will see things in here. Now we get to talk about commands. Isn't it wonderful? Finally, you get to actually run some commands in Linux. So we're just going to talk about a few. There will be plenty more in future videos in this series, but for right now, let's just talk about these three. These are going to be the three that matter the most to you, at least for right now. So for navigating, the first thing you want to do when you go into Linux, or possibly when you just don't know where you are, is a PWD. A PWD will print your working directory. So printing your working directory is just going to tell you what directory am I in, and it will print the full path to that thing. The full path, anytime I talk about a full or direct or absolute path, I'm talking about from the root directory, how do you get to that other directory we're talking about? So I will show a quick example of that a little bit further on, but do keep in mind that if you ever want to see the full path to where you currently are, PWD is how you would do it. The next thing is CD, which stands for change directory. So if you're ever trying to go into another directory or folder, the way you would do that is you would type CD and then the name of the location you want to get to. You can do this with a full or relative path. When I talk about a relative path, I mean from where I currently am right now, how do I get to that location? So the best way to do that is generally going to be if I use a relative path. Typing in the absolute path every single time you're trying to CD to a new location may be a bit cumbersome. So, for instance, if I am somewhere in var right now and I want to get to home Goku, the way I would do that is I would type cd space /home /Goku. But if I'm already in /home, I can just type cd Goku because that is going to be directly underneath where I currently am. If I am already in Goku and I want to get back to home, the way I would do that is I could either do a cd space /home, or I could do a cd space .. So .. means your parent directory, aka the directory directly above where you currently are. Another little tidbit is that dot means your current directory, so where you currently are. We will look a little bit more about what that looks like a little bit later on, but for right now, I think that should get you pretty good. If you have any questions, please feel free to leave them on the YouTube link. So the next thing we're going to talk about is something else you're going to type just plenty. So ls, it means to list. List the contents of a directory. Whenever I say dir, I'm referring to a directory. That's how you'll see that abbreviated in the future. So with almost every command that you can run in Linux, there will be something called a flag. A flag is going to be an extra, generally character or word that you can append to a command to do extra things. So ls would list the contents of a directory. So if I did ls /home /bulma, I would get all of the contents in Bulma's directory. If I wanted to look at the metadata of every single file in there, I could do an ls space -l /home /bulma. Same thing with if I wanted to see her hidden files, and a hidden file is always going to be a file that begins with a dot, I could do ls space -a /home /bulma, and that would give me everything in there. You can do an ls. If you just do an ls with no argument, an argument is just whatever you're passing that command. So in the ls space /home /bulma, /home /bulma is the argument to ls. So if you give no arguments and you just do an ls and you hit enter, that will give you the contents of your current directory wherever you are. You can do that with a full path, a relative path, or nothing, and it'll give you your current. So if I do an ls space -l H, which in ls you can tag them all together. So you can do an ls space dash lah if you wanted. But in a lot of other in a lot of other programs that you run, or a lot of other commands that you run, you would have to do dash l space dash a space dash h. But ls at least allows you to sort of tag them all together. So if I did a ls-l, it will give me metadata related to the size of the file, the name of the file, who's allowed to access the file, but it will give it to me in more computer readable terms, which means that you're generally going to get the size of the file in all bytes. So if the file is several gigs or terabytes, that's kind of a lot of bytes to look at. And the average human, although you can figure that out and you'll get really good at figuring that out as you deal with Linux more and more, -h makes it a little bit easier because it'll translate like 1,000 bytes into 1 kilobyte, for instance, instead of 1,000. So it makes it a little bit easier, and it'll do each order of magnitude. So you'll get kilobytes or megabytes or terabytes or gigabytes, whatever it is, and it would be represented by like KB or GB or MB, something like that. So if I wanted to do an LAH, that would show me every file and directory in that directory. It would show me all the hidden files if there are any, and it would show me all of that in human readable format. Okay, so let's see. Oh, so this is a fun fact. I am not going to read the whole thing right now, but basically dot and dot dot are always going to be within whatever directory you look at if you do an ls space dash a. And dash a will show you all those hidden files, but it will also show you dot and dot dot. And so it's always going to tell you your current directory as well as the directory above you. And if you do an L, so LA, then you will see the permissions and metadata associated with your current directory as well as the directory right above you. So things to keep in mind. I've got some great little articles here that you can read by Rob Pike, who helped design some of the early versions of Unix, and then the Stack Exchange article where I found some data related to the history of the hidden file as well as the parent and current directory links in Linux. Okay, so now let's talk about the directory structure. So this is sort of your first exposure to actually looking at somebody type commands. Let me go ahead and explain what I've got on the left and the right here. So on the left, I've got a terminal or console, and then on the right, I've got Mac OS X's Finder. If you are familiar with Windows versus OS X, Finder is just the Windows File Explorer. Basically, it's the Mac version of that. It looks pretty similar, so I don't think it should be too hard for anybody to follow along with, but just noting that. So on the left-hand side, I have, let me go ahead and use, okay, right there. So right here, so the first thing there is a smiley face. That's specific to my prompt. In Linux, you're always going to have what's called a prompt here, and that is the thing right before where you would enter in text. So the reason I have a smiley face there is anytime you see the smiley face, that means that the command executed successfully, so nothing failed. Anytime you see, as in right here, a shocked, scared face, that means that things went poorly and failed. I will most certainly link how to do this in your own terminal later, but for right now, that's basically all you need to know. The next thing is going to be my user, and my user here is Domo, and then the time. Every prompt that you see is going to be slightly different, but in my case, this is the way I have formatted it, and you can look into how to format your own later. Possibly I might do a video on all the different fun things you can do with that. But jumping right into it, the first thing I run here is a pwd. So that's me printing my working directory. So this is where I currently am. I am in home domo internet. Then I type a tree, which I didn't go over this command, but it basically just does a tree from your current directory down. So this makes it a little bit easier to visualize what I'm looking at. So it looks like there's a directory called aw, a file called list o favorite websites, and then another directory called memes, and then within those two directories I have two files in memes and one file in aw. So that then is confirmed down here with three directories and three files total. So one in my current directory, and then two in this one, and then one in this one. So then I do an ls with nothing next to it, and the ls just gives me those three files, or two directories and one file. And I have colors turned on with ls, so it will always show me what is a directory and what is a file. All the directories will always appear as purple generally, and then files will appear as either nothing, which in my case is just going to be the same color as I made the rest of my terminal, which is blue, or they will appear as pink, which means they're more accessible to other people around the operating system. So from here, what I do is I do a change directory into the directory called memes. I do an ls, and we see a directory called Rage Comics, and then in there we also see a file called soon.png. So that follows what we saw appear in the tree. So from there I decide, oh, I want to do a cd aw. And if you remember, this is me trying to call a relative path. I try to do that and it fails, as you can see the upset face right here. So it says no such file or directory. That didn't work because I tried to go into something that doesn't actually exist in my current directory. So I do a pwd to try and figure out where I am and what went wrong. I notice that I'm in home domo internet memes. When I see that, then I'm like, oh, okay, well how about I call the direct path to where I'm actually trying to get. So then I do a cd home domo internet aw. I do another tree and I see where I am, and I can see that I have one file in here and it is called baby panda. So that is the same as we see in this tree right here. So the reason I explain this is because one of the biggest newbie mistakes that I get people asking me about is they went into some particular directory and then they tried to cd into a relative path of another directory and it fails, and they ask me, but why does it fail? I just saw that thing. So the first thing you should always do is a pwd. On the right hand side, I have basically the same thing happening, but with the GUI, the graphical user interface, versus the CLI, the command line interface. So over here, I have a folder, again, called Internet, and then in there I have the folder called aw, and the folder called memes, and then the file called list of favorite websites. So I double-click memes, and I go into memes, and then I want to go into aw, but you'll notice there's no aw in here because I'm already in memes. So I would have to go up a directory first and then go into aw if I wanted to look in there. And that's why I put the little question mark here. So I wanted to make it a little bit easier to visualize if you saw this. That is pretty much it for this for this whole little I guess slide deck lecture. But I did want to do a really quick look at my own terminal. So this is my personal server. You'll see me kind of use this a lot because I feel like it's the best possible way that I can explain things to you guys. So if I do an ls of where I currently am, I'm in that internet directory I told you guys about before. So here's a pwd, a print working directory, so we can see home domo internet, and then in there I have all of these different files. I've added some more in here, and then I have memes and aw. So let's do an ls-a, and here we can see the current directory that we're in as well as the parent directory, and then these two directories, and then these three files. So if I do an ls-l, now we can see the metadata associated with these things. We've got some permissions here, and we'll go over what this output means later. But for right now, we've got like permissions here, and then we've got like more ownership permissions and stuff like that. Here's the size that I was talking about before. And then here's a timestamp, and then here's the actual name of each file. So if I did an ls-a, I could also see the same thing for my current directory, as well as my parent directory, And then if I do it again with an H, now these things are actually human readable format in size. And then if I go into, another command I should teach you right now is if you type clear, it will clear out your screen. All of that is still available above if you just scroll up, but this makes it a little bit easier for you guys to focus on what I'm doing right now. So another POWD, doing an ls, then I cd into memes, do an ls. I've got two things in here, do a PWD. This is where I currently am. Then I can do a cd dot dot, and then I do a PWD again, and you'll notice I am back into the same place I was before. If I do a tree, I can see the full structure here. So that's pretty much it for right now. If you have any questions, please feel free to add them to the YouTube video, and I will be putting some homework on my website, this video on my website, as well as in another week or two, I will shoot another video about how to do more things in Linux. I hope you guys enjoyed yourselves, and I will talk to you soon.